So what we're going to look at here is cloud formation and different types of clouds. First, we want to go through a quick little review on how the atmosphere is warm. Again, we have the sun. The sun's going to shine its rays, radiation, which is just another form of light. And that radiation is being absorbed by the ground mostly. Now, when that ground on the Earth gets heated up, it's going to heat up just that bottom layer of the atmosphere. And then that bottom layer of the atmosphere can begin to rise potentially in a convection current. All right, where it gives off its heat at the top, all right, warming the surrounding atmosphere, and then that air sinks back down. All right, so that's the quick review of what we covered in the second VCAS on how clouds form, or excuse me, on the atmosphere is warmed. But if we want to pick apart the details on how to make a cloud, there's several different parts that we can get a little more detail with. First off, you do need air rising. And like that last animation I showed, it could be due to convection. All right, the fact that warm air is rising because it's less dense. All right, and certain types of clouds are actually associated with this kind of lift, but it's not the only kind of lift that you have. You can also have when air is converging, it's running into each other, and when it runs into each other, it has nowhere else to go except being pushed up. And on weather maps, you can see that those locations where air is converging as low pressure systems. All right, anywhere there's an L, air is being pulled into it. As it nears the center, it converges and then rises upwards. You can also have something called frontal lift. Now, along with the L's, all right, for low pressure, you have these different fronts coming off of the L's. And those are when you can have air rising off of that when air behind, say this blue line here, has a certain property being cold and dense, and air in front of it is warm and moist, okay, which makes it very low density. And when you put those two different air masses together, the lower density of the two air masses will always be forced to rise. We could also have the fourth kind, which is orographic. Orographic is kind of cool because as air hits a mountain, the actual land is forcing the air up to rise. All right, and you can see that on all these little mountains. Air is being forced up the side of the mountain, and when it gets near the top of the mountain, it begins to form clouds. So as that air rises, okay, first off, it starts out with a certain temperature and certain dew point. It will rise, and since the pressure around it is lower, it's going to actually expand. That expansion causes it to cool down. All right, it originally was at 20 degrees Celsius here. Now it's at 15. Notice that the dew point temperature hasn't changed. All right, it's going to rise a little bit more. It's going to cool off a bit more as it expands. All right, and it continues to rise in that fashion until it reaches its dew point. Now, what is the dew point? Back when we talked in a previous video, the dew point is the temperature at which the air becomes saturated. That beyond it's reached the maximum amount that the air can hold. Now, again, it's not really the air holding up this water vapor, but that's how we will describe it for now. So it hits this dew point. Now, if that air were to rise any further, okay, past this height that it reached its dew point, first off, that height that it reached its dew point is called the LCL. That'll be important for later on. It's called the lifted condensation level. Because if the air were to be forced to rise beyond this point, it would still have to cool due to expansion, but water would have to condense. And when that happens, water vapor condenses to form cloud droplets, and you have a cloud. All right, the air would still continue to cool off, but notice how the dew point temperature drops, because now that it's lost a little bit of water, it can go down a little bit more in temperature. And it would continue to rise and form clouds. But when it condenses, all right, first off, it needs condensation nuclei. This is dust. These are, smoke particles. It's salt crystals. Any kind of junk floating in the atmosphere that's very small, some kind of aerosol particle, it will act like a surface to condense on. If you think of the summertime right now, it's very humid outside. If you put a glass of cold iced tea or lemonade out, it looks like the glass is sweating. Well, it's not sweating actually from the inside. What you're doing is you're taking air that's very humid, it touches that glass, and the water vapor that's in the air will condense into a liquid form from the air onto that cold glass. Now, it's important also to know that condensation nuclei cloud droplets are not rain droplets. Not yet, at least. Okay. The cloud isn't actually suspended rain droplets. Okay. It is liquid. And they're very, very small, okay, droplets of liquid water, right? But you would have to coalesce a bunch of these cloud droplets to make, your average sized rain droplets. So we'll get to that later when we talk about precipitation types. But it's not rain floating necessarily. It's cloud droplets. So let's talk about some different kinds of clouds. I've got about a half a dozen here that I want to talk about, but there's so many more out there. First off, cirrus clouds. Cirrus clouds are these wispy, very high altitude clouds. They're composed completely of ice crystals. For the most part, everything after this is made out of those liquid cloud droplets. But these things are so high up, they're actually so cold that they're formed primarily out of ice crystals. There's no precipitation with these. If you really get into weather, when you see cirrus clouds like this, it could mean that within a few days, you are going to get some kind of precipitation, usually like a day or to 3 days ahead of a warm front moving in, I believe, when you get some rain. So those are cirrus clouds. Stratus clouds. Okay, stratus clouds, you get a gray day outside where the sky is just completely covered. These are stratus clouds. They're like layers, all right? We're going to use the word strata in geology, or maybe, depending on when you watch this, maybe we already have, strata as layers of rock. So that's what that root word means, just layers. There's no precipitation here. They're just really wide, kind of thin, can form in different layers. Now, there's a prefix or a suffix that you can tack onto some of these cloud types and change the fact that there is no precipitation. In fact, if you get a Nimbo stratus, it's still a stratus of layers, but the Nimbo means there is precipitation. Okay, you're going to get light rain for a long period of time, like all day long, or maybe several days. All right, of rain. You're probably laying underneath a bunch of Nimbo stratus clouds. Okay, so not a whole lot different than stratus clouds, other than they are darker because they're more laden with water and can produce precipitation. That's why the Nimbo is meaning precipitation. Let's go with cumulus clouds, little cotton ball fair weather clouds. All right. There's not going to be precipitation with these. All right. But you can, again, tack on that nimbus or Nimbo to it to make a cumulonimbus. All right. These look like they have anvil, or like an anvil, where it's really wide on the top. They are specifically associated with convection currents. All right, that really fast, high-moving, high-energy. We'll talk about a little bit more, maybe in depth, when we get into, if we talk about stability of the atmosphere. Very unstable atmosphere where air rises very rapidly, producing lots and lots of energy. You can get thunderstorms that are associated with these. If you, a little subtype or something that's associated with the most severe thunderstorms are these really cool looking clouds, mammatus clouds. No precipitation with them, but the most severe weather, most severe thunderstorms, usually you'll see these mammatus clouds around them. Very cool looking clouds. So that's the basics of cloud formation and a couple other different types of clouds. There's so many other kinds of clouds that are out there, though, that, we can't sit here and go over them all. But they are really, really cool.